All right, welcome to the lesson about blueprints. You've heard about them, right? So let's just get into it. All right. So Blueprint is a complete gameplay scripting system. And by saying complete, I mean it. Because this character is actually a blueprint. So let's click here, edit. So we have this as a separate window. If you want, you can drag and drop this window right here next to the level window. So let's take a look. Right now, you see the event graph. You can zoom in and out with your mouse wheel. Use your right mouse button to move around, just like this. So we have these three windows here: event graph, construction script, and viewport. Let's start with the viewport. You can see that kind of similar to the editor, to the mesh editor that we used in the previous lessons. This window where you can view and manipulate your blueprint's components. So for example, you can select the capsule component. You can see that the component is selected here. If you select camera, the camera is selected. Here you can see the details for the component that you selected. Now let's go back to the event graph. So again, zoom in and out with your mouse wheel or right click to move around. The event graph contains a node graph that uses events and function calls to perform actions in response to gameplay events. A graph is a network of nodes. Every element, like this, it's called node. So all these are different nodes. And everything that happens in the event graph happens only at runtime. So if you change something in the scene while game is not playing, you won't see any changes. Only when you run the game, you'll see them. Okay? And with the construction script, you will see the changes because the construction script is executed when the object is initiated in the engine. It doesn't sound very easy, but let's take a look at what we have here. So this blueprint already has a few nodes, and every node is connected somehow. And these connections perform some actions in the game, right? For example, if you take a look at this movement, input, gamepad, and mouse node graphs, you can see that it starts with the input move forward. Then this is function, add movement input, and then to it goes to get forward vector and get control rotation. I don't expect you to understand how it works right now. It's just your first look at these nodes, okay? So this sign, this F, that means function. So we can understand that these three nodes are functions. Then, for example, here, jump. So this node graph manages jumps. So if the jump key is pressed, then jump. If released, stop jumping. Inside this node, we have the function jump. Inside this one, stop jumping. You can see that we have this simulating. If you go back to your level and click stop, then come back to the event graph and the text disappeared. Again, let's play, go back, and you see we have this yellow frame and big yellow word simulating. Let's go back, click stop. All right. You remember I said that everything that happens in the event graph happens only at runtime, and you will not see any changes when your game is not being played. So for example, now when the game is we're not in the playing mode, we don't see the character at all. Only when the game is played, only then we can see the character, and we can see how everything works here. You also can use these buttons here for the simulation. And if you accidentally closed your event graph, how to open it? You go here, event graph, and double click to open it. And construction script as well. Okay. If you need to select a few nodes together, you can just use your left mouse button like this. When you select a few nodes, you can usually just drag them together. But since this is one group of nodes, we can just drag it around like this. Now let's take a look here. So we have the event graph construction script, and here is variables. Probably you know what variables are, but if not, variables are properties that hold a value. And there are a lot of different types of variables. For example, let's click plus to create a new variable. We can give it a name. I'm just going to give it the test var variable name. And next to the name, you can see the type of the variable. You also can see this type here on the details panel. So as I mentioned, variables have a lot of different types. Let's click here. For example, what Boolean type means, it means yes or no. So there are a lot of type of variables, and in Unreal Engine, each type has its own color. So for example, Boolean is true or false. Float is a float number, meaning something like this with a point. We also have the integer, and it means whole number, like 1, 2, 3, 10, 20, 25. It's just whole number, no decimal, and other types. For example, we have the string type. It's a text string. For example, let's do like this. When the play begins, we see a string on the screen. So what we're gonna do, we're gonna add an event. Right click, and you can see all actions for this blueprint. So I'm gonna add event. I'm gonna find something that is close to begin play. You can do like this, like try to find. Oh, okay, here it is, event begin play. Or you can type here, begin, and it will show you everything that it has. Okay, so event begin play is here. Now don't forget to change the type to the string, like this. Next, we're gonna need to print string. Okay, you can see this is function, print string. So let's connect it like this. Okay, and if you want to connect two nodes together, you see it's very simple. If you want to disconnect them, Alt and left click. Connect, disconnect. Not all nodes can be connected together, but if they can be connected, you can see this green check mark. Then we need the variable. We're gonna drag and drop it to this blueprint like this, and it will always ask you, do you want to get it or you want to set the variable? In this case, I need to set my variable. And here we can see the text of the string. So let's put something like and if you click here, you can see more options for this function, like this. Also, very good thing that you can hover it like this and read description of a function. Prints a string to the log and optionally to the screen. It's development on this, so it's actually just for you to check if everything works. So it says print to screen and checked. Print to log, checked. Text color. Let's change it to red. Okay. Duration. This is how many seconds we will see the text. So I'm gonna put 10. Okay. Let's click compile and then save. Okay, now go back to the game, click play. Okay, and here is the string. 10 seconds, it should be here, and then after that, just go away. Yeah, all right, good. Stop. And that's how Blueprint works. You see, we started with the event, begin play. We found this event in this endless list of different events. There are a lot of different events here. Then we found the function that will print the string, and then we set the variable with this function. So just like this, using different variables and functions and events, you're gonna create a logic for your game. Instead of writing a code, you'll be creating nodes and connect them together. Just like this. You see, we connected them. And I know it might look scary, but just think about it. This system allows us to program without knowing C++. And learning C++ is way more difficult, believe me. In this course, your goal is to understand how essential elements of Unreal Engine 5 works. So let's go ahead and talk about node groups in the next lesson. In this lesson, I would like to talk about some elements of blueprints. So first, let's talk about event. In the last lesson, we have added this event begin play. So what events do is pretty obvious because for this one, for example, it means that all functionality that is after this node will be a response to this event. In this case, when the play starts. And I just want to remind you that we have a lot of preset events here. And you also can add your custom event. For example, let's say you want to set a health for a character in the beginning of the play. So we're gonna need the new variable. Let's call it health. Since it's health, we need to choose something that represents a number. We could choose float maybe, but that would mean that the number is decimal. So it's like 5.3. And for health, I think it doesn't look good. So for health points, it's usually 100, 95, 90, etc. So integer it is. Let's add the description. So if you want to set the health in the beginning of the play, you need to drag and drop this to your blueprint and set to whatever number, let's say 100, and connect it like this. So when you do like this and click play, you don't see any changes, right? That's because, yes, we set the health, but we didn't say, show me the health. We didn't say, print the health somewhere, right? We don't have any interface elements on the screen right now, because for a game, you would have some bars for health, for your weapons, but right now we don't have anything. So yeah, we did set the health, but we don't see it. And if you want to check that the health was set to this number, what you need is you need to print this information on the screen. So let's add a function. This is the function that you already know. It's print string. But instead of this, we're gonna open this up and connect the health to this side. And if you see that when you do like this, when you hover over this, when you hover it, you can see it says convert integer to string. That means that it would add this converter here. You can see it's different color because this variable is integer and this variable is string. So we can convert it first. We need to convert it first. Let's put 10 for the duration. Click compile, save, and play. All right, and here you can see the 100. It's the health points. We asked the system to show us this variable, and it did. That's it. So the print string is one of the functions, and you will use a lot of different functions when working with Unreal Engine. And basically, a function is a node that is called from another graph. Functions can be public, protected, or private. And you can see the description here on the screen. So the public function, this is the default setting, and that means that any object can call this function. Protected means that the function can only be called by the current blueprint as well as any blueprints that derive from the current blueprint. And private function means that only the current blueprint can call it. So to create a function, you can either use this list. There are a lot of different functions here. You can take a look. This sign means function. So all this are functions. Or if you need to create your own function, then you go here, functions, click here, function. New function was created. You can rename it. And you can delete it, just like this. And the final element that I want to show you is timeline. Timeline nodes provide time-based animation based on events, floats, vectors, or colors that can be triggered at keyframes along the timeline. They are specifically built for simple, non-cinematic tasks, such as opening doors. We will need timeline nodes for simple, time-based animation. And in the next video, I'm not only going to show you how to use timelines, but we're going to create our own blueprint and create some magic. All right, so you made it to this lesson. And in this lesson, we're going to create a blueprint, new one. Let's do it. So what we're going to do, we're just going to go back to the content drawer and create a new folder. I would say here in the content folder, you can click here, add new folder, and I'm gonna call it blueprint test. Because we have these blueprints here for the starter content, but I just want our blueprints to be in a separate folder. Double click to open the folder. And now let's add a blueprint. So add, and here we have some basic assets like blueprint, level, material, and Niagara system. And we need the blueprint class. So we need to pick parent class here. And you can see there are several types and even more here, a lot of them. But for now, I just want you to know that there is the actor class, which is very common class, character class, which is the blueprint for the character. You remember that the character that we have here has this icon for this blueprint. That means that his blueprint has the character class. For this lesson, I'm gonna choose the actor class. I'm gonna rename it to BP. Remember, I told you that it's best practice to rename your items accordingly. So BP for blueprint, M for material, and etc. I'm gonna call it ball because my plan is to create a ball here. Okay. Double click and drag and drop it here like this. Okay, so now we have the viewport opened and there is nothing here. That's because our blueprint is just empty. So we need to add something to it. So I'm gonna add a sphere. And since we have some assets imported to our project, you'll see the sphere right here. All right, here's the sphere. Let's take a look at the details. So the sphere is a static mesh. It has material, which is basic shape material. So let's click Save, Compile, and go back to our scene. And now I can drag and drop this ball to the scene. To put this ball on the floor, we need to move it a bit, like this. All right. Let's click Play. Okay. All right, so we see the sphere on the floor. And as you can see, it already has a collision. So let's go back to the blueprint. And you can see that when you create a new blueprint, there will be these 3 events drafted for you, okay? But these nodes are disabled and will not be called unless you add a node somewhere. And what I want to do is I want this ball or the sphere to disappear when the character touches it. To do it, first we need some kind of trigger. So let's add a collision. Add collision, box collision. Make it a bit bigger, like this. It's too much. Okay, we have this box collision, and this box collision is a trigger. So the script that we need is when the character touches the trigger, then the object disappears, right? So let's go back to the event graph. And you know what? This event actor begins overlap works for us just fine. You can check the description. Event when this actor overlaps another actor. For example, a player walking into a trigger. So, and what we need to destroy the object. When you're just experimenting around Unreal Engine, what you can do is do like this and then just type what you want to do. In this case, it's destroy. We're lucky and we have this destroy actor function, and we also have the destroy component function. But of course, if we choose destroy component function, nothing will happen, right? Because the component will be destroyed, but the ball itself, the sphere, still will be visible. So we need the destroy actor function. And we can see the target, which is self, and that means that this function works for this ball. All right, so let's save, compile, and try it. Bim. That's it. All right, let's do the other thing. Very simple again. So this time what I want to do is I want the sphere to change its color or change its material when the character touches it. And again, we're going to use this event because touch in this case means overlap. 2 collisions overlap each other. Right now, if we click here to the sphere, we can see that it has the basic shape material, but we have a lot of different materials here. So we can use some of them. So I'm going to select this node and just click delete. We're going to find the function. So what we want to change, we want to change the material. That means we want to set new material. So we want to set material. If we just type material, get a lot of different functions, but here, set material. So you see set material box or set material sphere. Actually, that's the elements that we have here. It's the components right here. And if I rename one of them box my and go back and type set material, you can see it says box my. So that's not just a sphere or a box, it's the components that we have created. So I'm going to change the material for the sphere because the box is just a collision. It doesn't have material. Okay. Whoop. Okay, very good. I'm gonna rename the box to just box again. All right, so let's select a material. For example, this one. And now I just need to connect this with the event, just like this. Okay, save, compile. Boom. So when the character touches it, the sphere changes its material. Awesome, right? Since we chose the set material for the sphere, the node sphere was created automatically, so you don't need to overthink it. The system has created the set material function and the target node, which is the sphere. Now it's time for a bit more complicated script. So I'm gonna close this one. You can see this sign that means that it's not saved. So basically you can just click Ctrl and S, can click Save All, and then it is saved. But we will not use the sphere anymore. Instead, we're gonna create a new blueprint. It will be the same class, the actor class, BP. We're gonna call it door, because it will be about door. Okay, again, I drag and drop it here. All right, so again, the viewport is empty, and what we need to do is to add something here. So what this blueprint for? I want the door to open when the player opens it. Okay, so we need to add a door here, and you can remember that we have in the folder props right here, we have a lot of different things, such as this door frame, and the door. Boom, together. Okay, so I'm gonna delete this for now, but that's what I want inside the blueprint. So to add this, we first need to add a mesh. So I'm gonna type mesh, and you see we have skeletal mesh, static mesh, and yeah, this is the mesh that we want to create, the static mesh. So this door is just a part of the door. So I'm gonna need another part. I'm gonna create a static mesh, and it's gonna create the door again, but instead of the door, I need the door frame. First, we need to rename it to door frame and door, and I can drag and drop it like this, so that now we have the door frame, and inside it we have the door. What we need to do is we need to move this door so that it fits the door frame. Let's do it. All right, so this is our door with the door frame. So now we need to add a trigger. Remember the way we did with the sphere, we need some kind of collision so that when a player enters the area, we can understand that it's happening. So let's add collision. Okay, I'm gonna use the box collision again, and we need to adjust its size. Yeah, that should be okay. Right now, the box is the part of the door frame. We can just move it like this. And now the box is not a part of the door frame anymore. Okay, so I'm gonna compile and save this and go to the event graph. So for this script, we don't need these nodes. So I'm just gonna use my left mouse to do like this and click delete. Okay, so first we need an event, right? So let's create an event. So what we need to do, we need to select the box and create a new event. So you can scroll down and see a lot of events that we have here. And in this case, we need this one, on component begin overlap. Let's click. It also says box because the box was selected. So this event will be called when something, like a character, overlaps the box, and the box is this collision box that we did. But we don't want all actors to start this script, right? We just need the character. So in this case, we need this over actor reference, and then we need to type cast to third person character. And this is the BP third person character. It's the way the blueprint for the character is called. If your character blueprint is called the other name, you'll see the other name here. And you see that this cast does. It tries to access object as a blueprint class it may be an instance of. So it will check if the actor that overlaps is the BP third person character. And if yes, then from this point, you can see this, it says exec, that means execute. And this, if no, then cast failed and something happens. So if it is the character, I want the player to push a button, for example, E button, to open the door. So if the character, which should be this character, overlaps the box, then I want to enable input. So what I want to do is I want to type input, enable input. You see that it has the player controller, so we need a player controller. Okay, just like this. So if something overlaps the box, then first we check if it's the BP third person character. And if yes, then we enable the input for the player controller. But we can't just leave it like this. We need to say what will happen if we end the overlap. For example, the character can touch the door, touch the box, then run away a few miles, and then the input still will be enabled. And if he pushed the button that we assign, then the door will open. And that's not what we want. So we need to go back to the box and choose on component and overlap. So that's this way we can end all this. And it's pretty the same. So again, we need to check if it's cast to BP third person character. It is. Again, we connect it like this. And this time, if yes, then disable input for the same player controller. All right, perfect. Let's save and compile. Now it's time to add a key that we will use to open and close the door. So you can choose whatever button you want. For example, let's choose the E button. E key. And okay, yeah, here they are. All the keys. So this is the E key. And you can see that it has pressed, released, and the key. I want the character to be able to open and close the door by pressing the E. So if you push E once, the door will open. If you push E the second time, it will close. That means that we basically have just the two positions, right? One is open, one is closed. And to manage them, we can use the flip-flop action. Here you go. Flip-flop is just two alternatives. When you press one, it does the A, and if you press the second time, it does the B. So what open door means, it means that this door, which is this part of the door frame, is rotated, right? So let's rotate it like this. Okay, 90 degrees. See it? And you can see here that we have rotated it along the z-axis 90 degrees. So, okay, let's go back to the script here. So I'm gonna drag and drop the mesh because I'm gonna change its settings. And then let me go back a bit. So we need the rotation. We have the set relative rotation. That's good, what we need to do. Set the rotation of the component relative to its parent. Okay, that works. So the target will be this door. Then the A is going here, and we change the z-axis to 90 degrees. And then let's just do like this. Select these two nodes, copy, Control C, Control V, okay, and B like this, and the new rotation will be just 0. Okay, we don't need this door. I think we just can connect it like this. All right, let's check. Compile, save. Okay, hold on. We need to put the door on the scene first. So I'm going to our folder, blueprint test, put the door right here, and then play the game. Okay. I have pressed E and the door opens and it lets me go through. Now I'm gonna click E again and it closed. And from the other side, oop. Okay. Okay. I think the right way to open the door is from this side. This is the right way to open the door, right? Okay, let's put minus so that it opens not to this side but to the other side. And I also see that we need to move the door a bit. You see this? You see the space between the door and the door frame? Doesn't look good. Okay, so I'll go back to the blueprint. Okay. Like this. Okay, and then go to the event graph and put minus here. Okay. Again, save, compile. It might not be the case in your case because it really depends how you put your door frame to this angle or to the other, but I don't want to redo this. Oh, I put the other door. Oh my god, I didn't want that. I didn't want that. Okay, play again. And let's open the door. Okay, it opens. It closes. Yay! I'm pushing E right now. I'm pushing E on my keyboard. If you assign the other button, then the other button will work. Okay, perfect. But if you want to go even more further, we can smooth this opening. You see, right now, it's not natural. It's not natural, you see. And we want to smooth this, right? Right now we have only two positions. One is here when the door is closed, and the other one is there when the door is opened. Let's use timeline to do this. So let's go back to the blueprint, and for now we don't need this. So I'm just gonna push out and click here to disconnect those. I'm gonna put this down. So let's add a timeline. So I'm gonna do timeline from this output. Timeline, add timeline. Timeline provides time-based animation based on events. It can really help with simple, not cinematic animations, and opening doors works just fine. So I'm gonna name it door. Open door. Okay, we have this inputs and this is outputs. Let's open the timeline by double clicking on it. And now we don't see anything here. There is nothing. So we need to add a track. Right here, track. We have float track, vector track, event, and even color. For these purposes, we can use the float track. And float track uses values. So right here, 0, and we can set a value, a float value here. Then here we can set the other value, and etc, etc, etc. If you want to make this, make the timeline bigger or smaller, you can just zoom in and out with your mouse button like this. And here you can see the length, which is 5 seconds. So what it does, by adding values here, 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 and here, you are saying, I want this value to be this number when it's on 0 second. Then on 0.25, I want this value to be this, and then this, and then this. And animation is moving actually through the timeline. So if you just take your hand and move it a bit, you can see that when you first start the movement, your hand is in some position, right? Let's say it's 0 position. Then you move it a bit higher. That means that in half a second, your hand is on this new position, which is, for example, 1.5. Then you move it a bit higher and it's 2. So your hand goes through 0 to 2 within, let's say, 1 second. And to add the value, you need to right-click on it and add key. This values, we call it keys. Where you click it, it will add the value. And for each value, you can click here. When it is selected, it is blue. You can see the time and the value. So, for example, here, time is 0.4 almost, and the value is 0.35. Here, the time will be 1. Let's add a key here. Almost 1. We can set 1. And we can set a value like this. You can see it. So I'm going to delete these keys and start from 0. Of course, because for the very beginning, we want the value to be 0. And what the value is, it actually will be this value, this rotation value. You see, we put 90 here, and that's what I want. But I just don't want it to be just 2 positions. I want it to be smooth. I put the first key here, put the time to 0 and value 0, and then after 1 second, I want it to be, I put 1 second, I want it to be minus 90. Okay, we don't see it now because the scale is not that big. So you can click here, zoom to fit vertical. All right, here you go. Okay, but the timeline is 5 seconds long. I think we can just put 1 second here. Okay, very good. Okay, and then since I want it to be smooth, I want to add a key somewhere here and then move the value a bit. Just like this. It's not very smooth. Let's click here, auto, and try to make it a bit smoother with the, okay. Yeah, something like this. And now when we go back to the event graph, we see the new track right here. let's rename it. Open door movement. Here's the door movement timeline. So I need this again right here. And actually for this one, we don't need the second one. The target will be the same, the door, but if right now I'll try to connect this timeline to this new rotation input, it doesn't let me because it is float and this is rotator, and you can see that it's not competitive. What to do? Good news, we have make rotator. Here you go. So now, let me just move it like this. So now it's gonna make rotator from this float. Instead of X, I think I'm gonna connect it to Z. Okay, and then to the rotator. Okay, very good. And I connected it to Z because, because you can see that we have changed the Z axis, and we also saw it here when we opened the door. Okay. Now we want to update this timeline. We're gonna connect this update output right here. It's gonna update in this, and for the flip-flop, we have A, we don't have B. So for B, what we want is just the reverse, right? So let's just connect it like this. Compile, save, let's try. Whoop! Ha! How smooth, huh? I like it. I do like it. Very good. Very smooth rotation. If you don't like the animation that you did, you can always open this timeline and correct it somehow. For example, we can, instead of 1 second, we can put, let's say, half a second. And in this case, whoop, a bit ugly. And in this case, the animation will be faster. So again, compile, save, and let's try. You see, a bit faster. And yeah, so you did all this. Congratulations. This is for you. This is for you. You did an amazing job, really, and I am proud of you. Now, when you know the basic things, let's do something that looks more like a game. Open the next part for this.